This question was asked in GATE 2021 for 2 marks. The torque provided by an engine is given by T of theta equal to 12,000 plus 2,500 sine of 2 theta in Newton meters, where theta is the angle turned by the crank from inner dead center. The mean speed of the engine is 200 rpm and it drives a machine that provides a constant resisting torque. If the variation of speed from the mean speed is not to exceed plus minus 0.5%, the minimum mass moment of inertia of the flywheel should be. And we have to round off the answer to the nearest integer. Now, in the earlier video on flywheel, I had mentioned that the crank rotation angle for one cycle of engine will be given in the question. If you have watched that video and understood properly, the crank rotation angle for one cycle is required mainly for two purposes. One, to calculate mean torque, and other, to find fluctuation of energy of flywheel in one cycle. But this question does not mention anything about the crank rotation angle for one cycle. Then how do we solve this question? If we pay attention to the expression for torque, we find the presence of sine 2 theta. This makes it redundant to provide any information regarding the crank rotation angle for one cycle. Let's understand this with the help of a diagram. This is how the diagram for the given torque expression would look like. Now one curve of sine theta is completed in 2 pi radians, but here we have sine of 2 theta. So in 2 pi radians we will have 2 sine curves as we have shown in the diagram. So one sine curve will be completed in pi radians. Now because it is a sine curve, this area and this area will be equal. And we are having one sine curve that is completed in pi radians. Now in terms of crank rotation, pi radians means that one stroke is completed. So no matter what type of engine it is, whether it is a 2-stroke or a 4-stroke engine, that information is not necessary because you get one complete sine curve in one stroke. And these areas will just cancel each other. And so we'll end up with the mean torque being equal to 12,000 Newton meter. So for this question, this itself is the mean torque. So we have T mean is 12,000 Newton meter. The next step is to find fluctuation of energy. So let's just mark the points where the actual torque diagram intersects the mean torque line. Now let's further understand why that information on crank rotation angle of one cycle is not required over here. Let's say that this area is A. Then the magnitude of this area is also going to be A since it is a sine curve. And so all of these areas are nothing but A. Now when we try to find fluctuation of energy, we assume that energy at point A is going to be equal to E. And so energy at point B will be energy at point A. Now this area is above the mean torque line. So this is energy in excess which will be stored in the flywheel. So we'll have the flywheel energy increase by amount A. And so this becomes E plus A. Now what happens to energy at point C? So energy at point C will be energy at point B. This area is now below the mean torque line. So it is energy in deficit. So the flywheel energy will reduce by A. And so this will be E plus A minus A, which will be equal to E. Then what will happen to energy at point D? So energy at point D will be energy at point C plus A, which becomes E plus A. Energy at point E, this will be energy at point D minus A. So that will be E plus A minus A, which is E. So as we see over here, the energy of flywheel at points A, B, C, D, E, etc. will just alternate between E and E plus A. So at A it was E, at B it was E plus A, at C it was E, D it is E plus A, E it will be E, F it will be E plus A, and so on. So we can say that the maximum energy that the flywheel has is E plus A and the minimum energy that it will have is E. And so the maximum fluctuation of energy delta E, which is E max minus E minimum, will be equal to E plus A minus E, which will be equal to A. Now what is this A equal to? It is this area, right? It is this much of area. So how do we find that area now? So this is midway of this sine curve, which will be pi by 2. So this A is nothing but it will be integral from 0 to pi by 2 of T of theta minus T mean with respect to theta. So this will be integral of 0 to pi by 2. What is T of theta? It is 12,000 plus 2,500 sine 2 theta. Minus the mean torque is 12,000 with respect to theta. So this 12,000 is cancels off and that 2,500 is constant. Integration of sine 2 theta will be minus cos 2 theta by 2 and the limits are 0 to pi by 2. So this will be minus 2,500 by 2, and on substituting the limits, at pi by 2 this will be cos of pi, which is minus 1, and at 0 it will be cos of 0, which is 1. So this is minus 2, minus n gets cancelled as well as 2, and so the maximum fluctuation of energy is 2,500 Newton meter. The maximum fluctuation of energy is 2,500 Newton meter. And now we can just apply the flywheel formula, that is delta E equal to I omega square Cs, to solve this question. So we have got delta E is 2,500, I is the moment of inertia to be found out. Now omega. The question says the mean speed is 200 rpm. So to make it in radians per second, this will be 2 pi into 200 by 60 squared. And the fluctuation of speed is given to us is plus minus 0.5%. So that is 1% total. So Cs will be 0.01. So when we do this calculation, we get I equal to 569.93 kg meter square. And they have asked to round it off to the nearest integer. So in nearest integer, the answer will be 570. So that will be the answer for this question. I hope you have understood the solution of this question. If you have not watched the earlier video on flywheel, where I have explained all the steps in detail along with another gate problem, I suggest you watch it right now. You'll find the link in the description below. Also subscribe to the channel if you haven't done yet, so that you do not miss out on more videos on gate preparation. And give a like if you find this helpful and share it with your friends. See you next time.